Alright, welcome again to Calculus. We're talking about graphs and models. This is part one. Okay, make sure you guys have a good, like I was talking about last time, make sure you have a good grasp of what a domain and range is for functions, but also you should have a good grasp of the graphs of functions. Okay, so basically, like I've always talked to my calculus kids, the more you remember from your geometry year, the better off you're going to be. Okay, so graphs of functions, you need to know your families of functions, like what each variable does, how it manipulates it, and how it changes it. So for example, if we're taking a look at y equals, let me see, what is that symbol? Alright, it is alt 251. The square root of x minus 2. Okay, that they would be able to understand that this is a square root function. Okay, that its domain is x is, let me see, I'm using these alt numbers, so alt 242, so x is greater than or equal to 2, so those are all the possible answers I can get. Okay, and my range is going to be y is alt 242 greater than or equal to 0. Okay, so just by knowing this information, I can basically look at this graph and tell you what its domain and range is going to be just by looking at it. So you have to be able to do that. Okay, representing a function numerically, you need to be able to look at a table and just see some information. So you need to be able to look at stuff and just see, you know, what's going on with the table of information. Vertical line test for function should be pretty simple. You use a vertical line. Desmos has a great way of doing that, in that you can, oh, and sorry, this is our introduction to calculus. Desmos is going to be your best friend because you can graph at the same time both a function, its derivative, its antiderivative, or its second derivative, you know, whichever ones you get. Now I know we haven't talked about those yet, but those do come up big time. So Desmos is a really good helper at noticing some interesting spots in calculus. Okay, so the vertical line test for a function just tells you, you know, is this a function or not. Piecewise defined functions are really interesting in that they are not continuous except on certain intervals, and they're just a lot of fun to work with. So for example, let's go to a new blank graph on here. Okay, now what I'm doing is I'm going to the keyboard part. Okay, let me move it over here so you can see the functions. And in order to do piecewise, you go into here, into the calculator portion. Nope, it's miscellaneous. And you could depend on, you know, which one you want. Do you want ceiling? Do you want floor graph? So you go ceiling x. Okay, so there's your piecewise there. Whereas if I did a floor version of x, okay, it would look something like this, which is just basically a step down from it. So ceiling covers one spot, that covers the other spot. So, you know, there's the two right there. You know, they just appear over each other, and it's kind of cool how it works. Okay, so that is piecewise function. Let me bring it back over. Okay, increasing and decreasing functions. So you need to be able to look at a graph and tell me if it's increasing or decreasing. So if I have a graph that's just funky and looking like this, you need to tell me when it's increasing. So the points of where it's increasing is actually well, it depends on speed. This point on this interval, it's increasing here, and from here to here it's increasing, whereas if I look right here, it is decreasing to 0, or it's decreasing down below. Oh, it starts here and ends over here. Okay, so you need to be able to tell increasing and decreasing functions. Plus, you need to look at the first, the constant in front, the coefficient in front, and be able to look at that too. Even in odd functions, you need to get familiar with this notation. Even functions is where you take you take the actual function, you plug in negative x, and you get out the same function. Okay? Whereas odd is where you take that negative x and you plug it in and you get out the exact opposite, which is the negative of the function. Okay, so if you're used to like looking at the graph and then going, oh, I noticed the symmetry, you can do that still, but you need to prove it by using the algebraic notation, okay? Common functions, you need to know everything you can about just common functions. Okay, so for example, as I'm looking in the book with you, let me see, boom, 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 boom. Do, 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 do. Let me see. Linear functions are common. Power functions, like what we just talked about, you know, just their normalities. Rational functions are things you need to know. So if you're lacking in any of these areas, you do need to contact us, okay? Alright, so it's just as simple as that. There's a ton more. There's certain cube roots. Here. No, I can't bring it over. Okay, and you do need to be able to look at like graphs and just tell me exactly what's going on. Like for example, if we go to Desmos, okay, let's get rid of these two. And let's actually graph one of these. This is a funky looking one. This is going to be a lot of fun. 3/4 parentheses x squared minus 1 all to the 2/3 power. Okay, and you need to be able to take a look at the graph and tell me, why does this hump appear? What happened here? What is going on here? You know, and there's some interesting things to be able to look at when you're looking at some funky ones that look like this. Okay, or even take a look at this one, which is 1 minus x, okay, which looks like a normal graph, but then I raise it to the 2/5 power, and I get something that looks like this. And it's really cool to see how this stuff just, you can get all kinds of different types of functions. Okay, you also need to know your sine, cosine, tangent, your secant, cosecant, and cotangent functions. Those are going to be hugely important for you guys to know. Okay? Alright, and if you guys get those and your exponential and your logarithmic, you know, it's only going to benefit you when you do this, okay? Alright, so that's pretty much it for just talking about graphs and models, and I'll talk to you next time.